Hi there everyone, and welcome to this quick little video on volume of prisms and cylinders. Now what we mean by prism is a 3D shape. So we'll be going through the different formulas that you need for a prism, for a rectangular prism, a triangular prism, and also a cylinder. And we'll have a look at some quick little examples together just to make sure that we have the technique understood. So let's get going. Now, when we are given a question like this, now we're given obviously a 3D rectangle here, our rectangular prism, we need to know three different things about it. Okay, we need to know the length of it, which is at the front here, right? We need to know the width of our rectangular prism, and we need to know the height. Okay, and that's where all these three things are. So these three letters, length, width, and height, are basically the three numbers that we need to know. Okay, now our formula for the volume of this shape, so the amount of space inside this prism, that's what volume refers to, the actual formula itself is equal to length times width times height. Okay, so that's our formula. We just multiply the three numbers. So let's have a little go at an example here on this second diagram. So if we just give this some random numbers, and let's go 2 centimeters, okay? The very first thing you need to be doing, so step number one, you need to write down the formula. So our formula for volume is equal to length times width times height, okay? So that's our formula. Now, we need to work out which one of these three numbers is our length, which one's our width, and which one's our height. Now you'll realize later on that it doesn't really matter in these simple questions which one your length is, which one your width is, and which one your height is, because you're just multiplying the three numbers. But when you get to trickier questions later on, it is important to figure out which one's which. So let's do that from the very beginning. Let's work out our length. Now if we compare this diagram to the one above here, we can see that the length is the long side down the bottom here, so therefore our 6 will be our length. The width up here is the width of the rectangle at the front, so our width is 3. And our height, this one here, is going to be 2. Okay, so step number 2, plug in the numbers into your formula. So we have V equals to, our length from here is 6, our width is 3, and our height is 2. Now when you plug these numbers into your calculator, you'll figure out that it comes to be 36 centimeters. Don't forget your units, okay? And because we're doing volume, it's going to be cubed, okay? Very, very important that we add this cubed part here, all right? So that's a nice little example on working out the volume of a rectangular prism. We have our formula at the top here, volume equals length times width times height. And then when we come across a question like this, we know we can work out which one is which. Now this particular rectangular prism, it doesn't have to be lying down like this, it can be standing up. So in other words, it can look something like that. If we just bring that into the screen, right? So it can be standing up, or it could be on an angle, or who knows what they come up with in questions, all right? So it's not always going to be nice and simple like this, but this is the formula that you're using. Okay, let's have a look now. Quick little example and a look at our triangular prism. So we're moving on to the bottom drawing here, this second last drawing on our page. Now with our triangular prisms, again, there are three things that we need to know about this, this shape before we can work out the volume. Okay, the very first thing you need to know is the base, how long the base of it is. And the base, we give that a little b, a lowercase b, and that's the length of the bottom of this triangle here at the front. Okay, so that's our base. The other thing that we need to know is our height. And again, we give that a capital H, and the height is always the long part of our shape. So if you imagine this whole thing standing up on one of its ends, this will be how tall it is. Okay? And finally, the last thing that we need to know is how tall this triangle at the front here actually is. Okay? And we give that a lowercase h like that. So those are the three things. The base here, we need to know how high it is, the height, and again the height of the actual triangle at the front, okay, which is basically the height of the whole shape anywhere you're looking at it. All right. And if we are to come up with a formula for this, our formula will look something like this. Let's write it up here. So V equals a half times base times the height of the triangle times the height of the overall shape. Okay, so that's what our formula looks like for anything like this. And this is the formula for any triangular prism that you come across. Okay, you need to know the height of the triangle, you need to know the base and the height of it. So now that we know the formula and we have the basic idea down, let's have a go at a quick little example. So if again we just add some numbers in here, let's go 4 millimeters and let's go 12. Okay, what we can do again, the very first thing is identify which shape we're dealing with and what formula we need. So again, we're looking at a triangular prism here, so we need the formula for from above. So volume equals a half times the base times the height of the triangle, times the height of the whole shape. Okay, and next up we need to take each of these numbers and plug them into our formula. So again, if we go back to our original shape here, we know from above that the base here, the B, is 10, so we can call that little b. The height of our triangular prism is going to be 4, and the actual height of the triangle at the front there, we can give that a little h. Okay, so now we substitute each of these numbers into our formula that we've already written. So we have V equals 1/2 times 10 times 12 times 4. Okay, and when you plug that into the calculator just the way it looks there, so 1/2 times 10 times 12 times 4, you come up with 240. In this case we have millimeters. Okay, don't forget your units, and again it's millimeters cubed because we're looking at volume. Very, very important. So there are some quick little examples. Remember, you can always go back and have a look at them again, pause the video, up to you. What we are going to do next is have a look at some more shapes. So next up we have cylinders. Okay, so again we're looking at the volume of these shapes, and it can be a little trickier for a number of reasons, but we'll go through some examples together. Now, the very first thing that we need to know about this shape is the actual formula that we're using, right? So V equals pi times r squared, and I'll explain what all that means in a second, times h, and that stands for height. Now, let's have a look at what this r means and what the h means. Okay, so on our cylinder, the height, this capital H, the height of the cylinder is going to be this long side over here. So we give that a capital H, okay? And the r, the little lowercase r, stands for the radius of the circle at the top or at the bottom, okay? So the radius, remembering, is that it is from halfway in the circle to the edge, to one side, okay? So that's going to be our radius, just like that. So all you need is the radius and the height. Now what they will do in some cases, in some questions, instead of giving you the radius and making it nice and simple for you, they will give you the diameter, which is from one side of the circle to the other side of the circle. Alright, so if they give you the diameter, which is from one side to the other, what you need to do is divide that number in 2, right? So then you have your radius. Okay, so that's just one extra step, and we'll have a look at an example in a second. So let's use the same picture here and give this diagram some numbers. So let's say that our radius is going to be 3 centimeters and our height will be 13 centimeters. Okay, again, we've got our formula, we use that formula there, and we substitute the numbers into our formula. So we have pi, stays as pi, it's on your calculator, times the radius squared, which in this case it's 3 squared, times the height, which is 13. Okay, now if you write this into your calculator just as it is, nothing more, nothing less, okay, in that order and everything like that, you come to an answer of 367.56 centimeters cubed, always remembering that cubed part there. Okay, so that's how simple it is to work out the volume of a cylinder. As long as you know the formula, And the formula is right there for you. Copy it down, memorize it if you have to, and use it when it's needed, obviously. Let's have a look at one more quick example with cylinders. There's another nice little cylinder for us there. Now in this case, what they're going to do in this question or this example is actually give you the diameter. Okay, so they're going to give you the diameter, which let's say is 10 centimeters, and the height they're going to say is 21 centimeters. Okay, so again, very first thing that we've got to do, let's get our black pen. Very first thing that we're doing is we're writing down the formula for this cylinder. Okay, so V equals pi times the radius squared times the height. Okay, now like I said before, this requires one extra step because we don't actually have that radius up here. We are given the diameter of this circle from one side to the other. We only need to know the radius, which is half from the center of the circle to one end. Okay, so the first thing that we've got to do is actually divide that 10 by 2, and we are given 5 centimeters. Okay, so this will be our radius. Next up, we take our formula, which is written up here, and substitute the numbers in, remembering we are using this 5 centimeters instead of the 10. Okay, and we talked about that before. So we have pi times the radius squared, the radius is 5 squared, times our height, which is the capital H up here, the height is 21 centimeters. Nope, let's move that along that way. There we go. So again, we take our calculator and we plug these numbers into it, and what we come up with, so volume is going to equal 1,649.33 centimeters cubed. Very, very important. Like I said, I keep saying that. I know I'm repeating myself, but that cubed is very, very important. Okay? So, there's two different examples on how to calculate volume of a cylinder. Again, remember you can always go back and re-watch the video or pause it or whatever you'd like. But before we finish up, I want to look at one more quick example of a composite prism. So what we're looking at here, if that focuses for me, there we go. What we're looking at here is a shape made up of two or more shapes, basically. Okay, so we can see the measurements on here already. Hopefully they're clear to see. 10 millimeters, 80 millimeters, and so on and so forth. The tricky part to this is that you can't just work out the volume of this whole L shape from the beginning. What you need to do is you need to break this shape up, divide it into two or more shapes. Okay, in this case, because it's a nice simple shape, we can divide it into two different shapes. So there are two ways we can do this. We can either draw a line down this way, okay, and we break it up that way like that. So we have one shape is from this red line onwards, the bottom part of the L. That's one shape, and we can call that shape number 1. And the second shape is this tall tower over here, and we can call that shape number 2. Okay, if I can write properly. There we go. So what you'd need to do is you'd work out the volume of shape number 1 and work out the shape of the volume, of shape number 2, and add the two volumes together. All right. Now, what I suggest you do is you draw the shapes out separately. So you'd have shape number 1. Now I can't draw properly, so you'd have to bear with me here for a second, right, because drawing is not my forte. So this is shape number 1 roughly. Okay, so we have shape number 1, and we can label it as shape number 1. Okay, and you'd have to work out the different sides of that shape. So we'd go ahead and label this as 10 millimeters down here. Okay, now the bottom part here, the length of this shape, if we have a look at the original shape, we know that from one side to the other it's 80 millimeters, but from here to here, which is what we need, is 60 millimeters. So the length of it is going to be 60 millimeters. Okay, and we can work out the height, or the width, of this shape by again looking at what we know. So we know that the whole thing is 60 millimeters, from the top to the bottom is 60 millimeters, but from here, from the very top to halfway, it's 40 millimeters. So therefore, if from here to here it's 40 millimeters, we need to get to 60 millimeters. How much have we got from 40 to get to 60 down here? we have 20 millimeters. So this side here, the width is going to be 20 millimeters. Okay? And just like before, we work out the volume of the shape using our formula. So we write down the formula. First thing you need to do is write down the formula. So volume equals length times width times height. Okay? Let's put a number 1 there. And what you need to do now is work out which one of these numbers is your length, which one is your width, and which one is your height. So going back to what we looked at before at the example, we know that the long side down the front is going to be our length. All right. The width of the rectangle at the front, we give that a W, and this side over here is going to be our H, our height. Okay. So then we again substitute the numbers in. So volume equals length, which is 60 times 20 times 10. Okay. And you grab a calculator and you plug these numbers in and you get 12,000 millimeters cubed, okay, because we are working with volume. So you've worked out the volume of the first shape, and I suggest you highlight it or underline it or anything like that, because you need to work out now the volume of the next shape. So if we look at shape number 2, let's do it in a different color so we don't get confused here. If we look at shape number 2, this is, again, it's a rectangular prism, but this time it's actually kind of standing up. So if we draw this nice and quickly, just like that, okay, and we call it shape number 2, all right, we can again label it appropriately with the numbers that we know. So if we look, we know that this side here is corresponding to this side on our shape, so that's going to be 60 millimeters. Okay, now we need to know the depth. Let's have a look at the depth or the height, the capital H that we give it. Okay, it's this side here, and it's going to be the same as our original shape. Okay, so that doesn't change, so that's going to be 10 millimeters. And the other side that we need to know, or the last side that we need to know, is this bottom part here. Okay, now again, if we go back to our original shape and we have a look that from one side to the other, our shape is 80 millimeters long, all right? And we also know that from here to here, where we divided our shape, it's 60 millimeters long, all right? So we go from here to here, 60 millimeters. How much further do we have to the other side to get to 80? We have 20 millimeters. So our bottom side here is going to be 20 millimeters long, okay? Next up, we write our formula down. Length times width times height, okay? Next, we need to work out which of these numbers is our length, which one is our width, and which one's our height. Now again, looking at this shape, the longest side of your rectangle here is going to be your length, so 60 will be our length. Our width will be the other side of our rectangle, so that's going to be our width, and the capital H, the height, will be our little side here, the 10 millimeters, okay? So again, we substitute the numbers in, so we have volume equals 60 times 20 times 10, okay? And plug these numbers into our calculator again, and we get the exact same thing. We get 12,000 millimeters cubed, okay? And again, like I said before, I suggest you underline it or highlight it or something like that so you know what you're looking at here. And now we have one final step that we need to complete. Now, like I said before, we're trying to work out the volume of this whole shape here, okay? We've worked out the volume of shape number 1, we've worked out the volume of shape number 2. Now what we need to do, so there's our answers circled and underlined for both of these shapes. Now all we need to do is add these two answers together, okay? So volume, let's find our small little step or space, sorry, underneath here. If we say volume of shape number 1 and shape number 2, all right, is equal to 12,000 plus 12,000. All right, and again, using our calculator or just doing it in our mind, we know that that is equal to 24,000 millimeters cubed. And there's our final answer. So we've split that shape up into two different shapes. We've worked out the volume of both of those shapes and added the two volumes together at the end. And that's our final answer. Well, I hope you've enjoyed this little video. I hope it's made some sense and it's helped you along in your work. I will post some more videos up. Keep an eye out, and don't forget, check out YouTube and teachertube.com to see some more of my videos and to subscribe. Bye bye.